All right, we need to find a sub r. This thing is swinging around this. So what I can say is the sum of the forces in the y are 0. Sum of the forces in the x is equal to mv squared over r. So we know that in the y, and I'll go ahead and break these up. This one, break like this. And this is going to be t2y, t2x, and then this one is going to be t1x and t1y. Okay, and so we know that t2y plus t1y is equal to mg. And then in the x direction, we know that t2x plus t1x is equal to mv squared over r. And then we begin all of our fun stuff. t2y is in fact t2, looks like sine 45, and t1y is t1 sine 37. And that's going to equal mg. t2x is t2 cos 45. t1x is t1 cos 37. And that equals mv squared over r. And of course, mv squared over r, do we have any other information? Okay. Oh, yeah, of course. We know that mv squared over I should have just put ma sub r, right? A sub r. That makes life much easier. Okay, don't have to put out mv squared over. So we just need to solve for a sub r. So it looks like, oh, and since I know that t1 is mg, that gives me t2 sine 45 plus mg sine 37 equals mg. So t2 equals mg minus mg sine 37 over sine 45. That gives me an actual value for t2. Calculator. So, oh, actually, we don't know what m is. Well, that's pretty much a nightmare. Intriguing. So then over here, we know this is ma sub r. So a sub r is going to equal t2 cos 45 plus mg cos 37 over m. Oh, okay, that must be. We can't, I don't know mass, it's just mg. Yikes. What a nightmare. But yeah, if we look here, this has an mg term, this one has an mg term in it. So if I plug t2 into here, there will be mg terms throughout, and we can cancel out the m's. So this is gonna hurt me worse than it hurts you, but it's some ugly algebra, and I guess we're just stuck with it. So we can say a sub r is equal, I'm going to factor out the mg just to make my life easier, 1 minus sine of 37 over sine of 45. And that's t2 right there. So then I multiply that by cosine of 45. And then we're going to get plus mg cosine 37. All of that is divided by m. So m cancels there. So a sub r, and this right here becomes cotangent 45. So we get, I can factor out the g's, I guess, and this becomes a god-awful mess. G times 1 minus sine 37 times cotangent of 45 plus cosine 37. And that should be it. And of course you have to plug in all those numbers and see what it is. 37, sine of 37 is around 0.8. So this becomes G times 0.2 times the cotangent of 45. That I do not know off the top of my head. Cosine 45 divided by sine 45. Oh, it's just 1. Haha, just kidding. Alright, and then plus the cosine. Oh wait, no, this is 0.6. So that means this becomes 0.4. 0.4 plus cosine 37, that's 0.8. So then this becomes 0.4 plus 0.8, so it's 1.2 G's. So 1.2 G is the radial acceleration.